Fibonacci sequence. So this algorithm, we're going to talk about how to generate the numbers of the Fibonacci sequence. So if you look at this particular pattern here, this is known as the Fibonacci sequence. So the only two or the starting numbers of this sequence happen to be 0 and 1. The next number 1 is the sum of the previous two numbers. So 0 plus 1 is 1. Now 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. So this particular thing keeps on proceeding forever. There is no end to the Fibonacci sequence. Now what this algorithm is expecting us to do is, given this first and second, it's expecting us to generate this particular pattern till the endpoint specified. So suppose n is just 8, I will be printing 0, 1, 1, 2, 3, 5 and 8. So in order to generate this particular pattern, it is very important to first understand how this sequence is being generated. So what I'll do is I'll call this 0 as the first number, this 1 as the second number, and how I'm calculating next happens to be first plus second. So it is 0 plus 1 is 1. Now in order to calculate 2, what I need to do is I need to move first to second and second to next. So first what is going to happen is the value of second will get copied to first, then the value of the current next will get copied to second, and the new next will be calculated as first plus second, which happens to be 1 plus 1, which is 2. Now how long should we generate these numbers? As long as the value of next is less than or equal to n. So n is the endpoint we are going to generate. So let's try to take a look at this body. So what we're trying to do here is I am copying the value of second to first, then I am copying the value of next to second, and I am calculating next as first plus second. How long do I do it? I do it as long as the value of next is less than or equal to n. So this is a while do loop which keeps on happening till I reach the value of n, that is next becomes equal to n. Now let us first go about trying to develop this logic, and then we'll go ahead and do the testing as usual. So before I even go ahead and do the remaining part of the logic, let me try to explain what are these variables. If you see, 0 happens to be first, 1 happens to be second, next is going to be first plus second. In order to generate this particular pattern, I need to know what is the endpoint or n. So what I'm going to say is I'm going to ask the user enter the value of n. Now in this do while loop or the while do loop, I am going to keep generating this pattern as long as the value of next happens to be less than or equal to n. So the first thing what I'm doing is take a look here. So what I'm doing now is I am first printing 0, then I am printing 1. Then I am entering into a loop. Let's say next is also 1 and n is just 8. So 1 is less than or equal to 8 is true. So I am first writing next. So the next one is also printed. Now it is quite easy. I am moving the value of second into first and the current value of next into second, and then I am saying next is now first plus second. So next is now 2. Is 2 less than or equal to 8? Yes. So I am writing 2. So next 2 is printed here. Now first is 1, second is also 1. So second, the value of second which is 1 moves to first. The value of next which is 2 moves into second. So this is 1, this is 2. So this is 1 plus 2 is 3, next is 3. So now if you see 3 is less than or equal to 8. This condition is true. 3 is printed. Now what happens is 2 moves into first, 3 moves into second. Okay, 2 plus 3 is 5. Next is 5. 5 is less than or equal to 8 is true. I am going to print 5. This particular thing will continue till the value of next reaches 13. At that point, this loop is going to fail because the condition is not true. And once I come out, I am just required to stop. Now, in order to understand the working of this particular logic, we'll just go through a test run. So using a test run, we are able to very easily verify whether the working of a given algorithm or a flowchart in future happens to be correct or not. So first is 0, second is 1, next is 1. I have asked the user, he's entered the value of n as 8. Once the user enters the value of n as 8, then what I'm supposed to do is I am going to write first and second. So on the output 0 is written, 1 is written. Okay, so first 0 gets written, then next 1 gets written. Alright, now what is happening is I need to get into this while loop. Next is 1. Is 1 less than or equal to 8? True. So what I am going to do is I am going to write 1. This 1 is written here. Alright, this next is 1 is written here. Now what I am doing here is I am moving the value of second to first. So second was 1, first also now has become 1. Next was 1. Okay, second also, now this 1 is moved from next to second. Second actually has not changed, but first has changed. Now next is first plus second. So it is 2. 2 is less than or equal to 8? True. So I am going to print 2. Okay. Now again what I do is I go ahead and I move these numbers, this fellow here and this fellow here. So first is again 1. Second has taken the value of next, which is 2. Next is 1 plus 2 is 3. 3 is less than or equal to 8 is true. So I am going to print 3. Then what happens is at this step I am going to continue the movement again like this. So if you draw arrows like this, it's very easy to develop the logic and understand what is happening. You need to understand that the order of this movement should be in the right step. You cannot do second is next first and then say first is second. Then the whole thing goes for a toss. That is the fundamental rule of an algorithm. Doing the steps in a right sequence or right order. Okay. So now what I'm doing is 2 is going to first. Okay. And 3 is going to second. Since this is going, next is 2 plus 3 is 5. 5 is less than or equal to 8 is true. So I am printing 5. Then I come here. In the next step, first becomes 3, second becomes 5. Next becomes 8. 8 is equal to 8. So still we are okay. So we are printing 8. Then we come back here. This fellow goes here. This fellow goes here. Whereas next becomes 5 plus 8 or 8 plus 5 is 13. 13 is not definitely less than or equal to 8. This loop fails and I come and stop. If you want to understand the working of this, take a larger value of n like 35 and 60. Run through the logic. Most important point, this sequence is very important. Second should first go to first. Next should then go to second. If you interchange the order of these steps, your whole output is going to be a mess. So that is what requires a little thinking or a little logic in writing an algorithm or flowchart. The order of steps is absolutely important because that's all there is left to logic.